In today's lecture, we will look at divergence of a vector. At the very outset, I would like to tell the students, if you know how to take the dot product of two vectors, then divergence will be very easy for you. In fact, it is very closely related to the concept of dot product of two vectors, except that instead of both being vector, here in the case of divergence, one is a del operator and the other is a vector. So let's look at this operation. Consider a vector given by v equal to vx of I plus vy of j plus vz of k. Then the divergence of v is written as this and is given by I dou by dou x. So we are writing the del operator j dou by dou y plus k dou by dou z. This operator is dotted with the vector v, vx of I plus vy of j plus vz of k. Just as we take dot product of two vectors, similarly we perform this operation. Therefore we get dou vx by dou x plus dou vy by dou y plus dou vz by dou z. This is a scalar quantity. Let's look at an example. Example 1. Let's choose the vector to be the following: v equal to x square I plus 3xz square j minus 2xz k. The divergence of v is given by dou by dou x of x square plus dou by dou y of 3xz square minus dou by dou z of 2xz. Performing the partial derivatives, we get 2x plus 0 minus 2x. So this gives me divergence as 0. Let us look at another example. Example 2. Now let us choose v to be y square I plus 2xy plus z square j plus 2yz k. The divergence of v is given by dou by dou x of y square plus dou by dou y of 2xy plus z square plus dou by dou z of 2yz. This gives me 0 plus 2x plus 2y, which can be written as 2 of x plus y. So as you can see, the divergence can be positive, negative, or 0. Let us understand the geometrical interpretation of divergence. Geometrical interpretation. So divergence of v, divergence of any vector v, gives a measure of how much a vector spreads out spreads out or diverges, hence the name divergence, from a point. Let me give you a couple of examples from physics so that this geometrical interpretation becomes clear. So, you all know that a positive charge has its electric field lines pointing outwards. If I were to take the divergence of the electric field for this point charge, its value will be positive. That is, the answer will be a positive scalar, hence indicating that there is a positive divergence of these field lines. And if you take a negative charge, we know that the electric field lines are pointing inward. And if we take the divergence of the electric field for this negative charge, then we will find that the divergence of the electric field is a negative quantity. And finally, if you look at electric fields lines like this, then if this electric field is given by E, then the divergence of this electric field will be 0. This completes the lecture on divergence operation.